rest of us, but because we are honored this evening to have Gary Dickerson, who is the President and CEO of Applied Materials. So, Mr. Dickerson was named President of Applied Materials in June 2012 and appointed CEO and a member of the Board of Directors in September 2013. He's a longtime industry leader, with more than 30 years of semiconductor experience and a strong track record of delivering profitable growth and gaining market share while achieving recognition for outstanding customer satisfaction. This evening, his talk is going to be about navigating the perfect storm, enabling the AI era. But before he comes up, we're going to have a small clip for you to view. All right, let's welcome Gary Dickerson to the stage.
Thank you. I'm really happy to be here tonight. So let me ask a question. How many people here have been to China in the last 12 months? Raise your hand. How about the last 2 days? Raise your hand. How many people here use WeChat? So I'm going to talk about this perfect storm. I definitely believe that there's never been a better time to be a Chinese American in the semiconductor industry. Never been a better time. So all of you with WeChat, how many people have been to China using cashless transactions? It's amazing. It's really amazing. So, you see technology transforming many industries. Transportation will change in fundamental ways. Healthcare, retail, education, many areas are changing in fundamental ways. And at the base of all of that change, at the foundation, is silicon, semiconductors. So again, I deeply believe never been a better time to be a Chinese American semiconductor professional. Also, I have a special tie to China myself. My wife is from Nanjing. And I just came back from China. I met with Vice President Wang actually on Thursday and many other people in China. And I am a deep believer. We can look at the current environment. Stock prices are not where we'd like to see them be. But I always think that in any situation, you have to have a point of view, certainly as a CEO, a point of view on direction and magnitude of any business. And I think really it comes down to faith and courage. What do you believe? And what you're going to see is I deeply believe what I said. There's never been a better time in this industry. And so for all of us, you're going to see short-term geopolitical issues, you'll see short-term issues in supply and demand, but I deeply believe there's never been a better time. And I also love what we do. I love the technology. And I also, when I'm with many young engineers, when we have our engineering technology conference, or in China, I met with many of our employees, I deeply get inspired by so many smart, passionate people that are a part of our industry. So I appreciate all of you. A round of applause for all those smart, passionate people. Okay, so let me start the talk now. The last century, oil was the foundation for the Industrial Revolution. And I deeply believe that data is the foundation for the biggest changes that we will all see in our lifetime. I'll talk today about AI and big data. We already see cashless transactions in China. We'll see many fundamental changes in the next decade. I believe that will happen faster and in larger ways than any of us can imagine. And when I'm talking to many people in the ecosystem or different governments, they believe, and I believe, that these technology transforming industries will create trillions of dollars of economic value. Trillions and trillions of dollars of economic value. And I'll talk about that some here today, and I'll also talk about a major challenge we have that could be the perfect storm or the perfect opportunity. So as I said, data is at the foundation. When you look at all of the different changes that are happening in our world, profound changes that are happening, you see everything getting smarter. You go to the Consumer Electronics Show, you have voice assistants with 30 chips, and there's so many things that are happening. IoT, sensors, all of those technologies. And we certainly see that in our business. Tremendous growth for smart devices generating data. And of course, to unlock that, you have to store all of that data, and unlocking the value, you have to process the data. Just like oil in the barrel isn't worth much, data that's not processed is also not worth very much. So the data generation, the storage, processing, and connecting all of that data, all of that is in the foundation, at the foundation of trillions and trillions of dollars of economic value, and silicon is really at the foundation of all of these elements that will transform industries. So if you look at the explosion of data, what happened in 2018, that was profound. On this graph, what you see, for the first time, machines are generating more data than humans. And when you think about, when I talk to people in the ecosystem, when you think about transportation, the future of transportation is going to change in fundamental ways. In the future, you'll have a vehicle generating 8 terabytes of data per day. So there's tremendous data generation. You need very low latency. Latency in an autonomous vehicle has very negative effects. So when you think about the whole nature of competition for transportation, when I meet auto CTOs, chief technology officers, their industry is going to be completely transformed in the next 10 years. Electric vehicles, smart vehicles. You'll see a new compute platform that is completely different than the electronics infrastructure today. Perception and sensing is also fundamental for the smart vehicles. And then you also have the applications layer with a digital cockpit. And it's interesting to me, when you talk to companies in the ecosystem, you talk to auto CTOs, they're already thinking about you and me when we're on a highway that's a controlled environment, getting on and off that highway. They're thinking about, we're there for 30 minutes or an hour, how are they going to make money off of us in that digital cockpit of the future? And again, the nature of competition is no longer about the driving experience, it's about the user experience. And all aspects of that platform will change in fundamental ways in the next 10 years. And again, silicon is a big part of the foundation for that new compute platform. The sensing, the perception, the user experience that's going to change how we live. All of that's going to happen. So then you think about, this change, what happens in the next few years. There's an enormous increase in data coming from machines going forward in the future. So that's why, for me, truthfully, I said before, you have to have a point of view on the future, and faith and courage. And I deeply believe this is why I tell all of you young Chinese-American semiconductor professionals, you're in the best place to make possible technology that shapes the future. It's never been more exciting. And AI has been around a long time, longer than Moore's Law. And why is it happening now? Why is AI starting to take hold now? Now you can store the data at the right cost, and you can also process the data at the right cost. Although what I'll show, if you look at the current architectures that we have today, If you keep going with the current architectures, studies I've seen says that by 2025 we'll consume 25% of the world's power with current chips. And obviously that's not going to work. So what has to happen is what has always happened in this semiconductor industry. Fundamental innovation. We will not get to where we need to go doing what we've done in the past. So again, the machine learning, the relentless classification of data to make predictions and determinations. That's at the foundation. So if you look at AI workloads, and you look at a CPU, and of course today GPUs are growing at a very fast pace. So what you see is your CPUs are designed for general purpose types of applications. And GPUs are more specific for AI workloads, so you can see many, many times the acceleration. Many times the acceleration with those types of devices. But going forward, as I said, studies indicate that if we don't innovate, if we do not innovate, you're going to consume an enormous amount of the world's power. When we have this new industry transformation that affects every part of our life, and silicon's at that foundation, we have to innovate. So you see more money going into chip startups in the last 18 months than we've seen in the last 18 years. To build chips in a different way. In-memory computing, many, many, many innovations beyond what we see today. That's also why I'm very excited. I honestly work every day, Saturday, Sunday, every single day. Those people at Applied Materials know that. And they work every day too. I think they would all say that. But it's so much fun. We're shaping the future. Our mission, our vision for Applied, make possible technology that shapes the future. We're at the foundation of the biggest changes we've ever seen. The war for AI leadership is the biggest battle of our lifetimes. And we're right at the foundation in enabling that future with many new technologies. Applied in July, we were at the DARPA Electronics Resurgence Initiative Conference. I gave a keynote there. We announced working with ARM on a neuromorphic switch where you can process and store data in the same material. These kinds of innovations in materials and structures are absolutely crucial to all of the profound changes that will happen in our lives over the next 10 years. So when I talk to companies in the ecosystem, I was with the CTO of a large fabless company here recently, and we were talking about edge and cloud, and really what is driving their business. And what we talked about is performance per watt is a huge driver and differentiator. When you think about power consumption at the edge, when you think about power consumption and energy consumption, performance per watt in the cloud, systems companies are saying we need to drive 1,000x improvement. Not 2x, not 3x, not 50%, 1,000x. So what that means, again, the great thing for all of us, it's a great challenge. I love that kind of challenge. Working together with all of you to make this future possible. But that's what we need to do if we really want to transform transportation with the data center on wheels and healthcare and retail and education, entertainment, so many different areas, So, we have this great opportunity, maybe $10 trillion in economic value that will be created by 2030. $10 trillion, the war for AI leadership, biggest battle of our lifetime. And at the same time, how many people here think Moore's Law is slowing down? How many of you think that? Not so many of you. A lot of you guys are optimistic. How many people think Moore's Law is slowing down? I think it's slowing down. But I also think there's a different path. So again, it's either a perfect storm or perfect opportunity. It is at the foundation of unlocking the most profound changes in our lifetime. So So if we look back to Moore's Law, these are very, very famous charts regarding Moore's Law. And if you look at what Gordon Moore did, you know, Figure 1 is kind of one of the most famous charts, but Figure 2 is where he took some data points and plotted them. And then later, maybe 10 years later, talked about doubling the number of transistors every 2 years. So if you take this and you plot it, that projection held for 40 years. That is really amazing for anyone to come up with something that's so profound. And I think one of the previous speakers talked about how Moore's Law fundamentally changed our lifetimes. How many people have a mobile phone with them tonight? How many people? Probably everybody. So you have this connectivity. You have really a data center in your pocket. You're capturing memories constantly of all the things that are happening in your lifetime. There's so many things that were enabled by Moore's Law. But if you look at what's happened over the last few years, this is slowing down. Moore's Law has been slowing down. So if you look also on the right here, this is a semiconductor analyst. They showed the most advanced technology node, instead of taking 2 years, taking 4 or 5 years. And then you have Amdahl's law on the left here with Professor Hennessy. And again, you see the same thing, that the technology rate of progress is slowing down. At the same time, we need 1,000 times improvement in performance per watt. So, what do designers want? There are many designers here. There are many fabless companies here. It's really power, performance, area, and cost, PPAC. Everyone is driving these kinds of improvements. And again, fundamentally, this is slowing down right now. It's getting harder to do with classic 2D feature shrinking. And I'll talk about really what are some of the things that we can do together, and certainly that what we're driving in applied materials to address this challenge. So I have to say, I am very optimistic. Maybe this part's not so good so far. We're going to get to some good stuff here in a minute. So I deeply believe that the current playbook is not going to work going forward. I think we have to address this challenge in a fundamentally different way. So new architectures, new structures, 3D structures, new materials, new ways to shrink, and packaging. And I'll cover these at a very high level here during the discussion. But I meet with CTOs of chip companies, I meet with CTOs of systems companies, you know, all through the whole ecosystem. Almost every week, probably I meet with 3 or 4 different people. And again, there's tremendous value in performance per watt improvements. And I also deeply believe, I'll show some examples, which is the tip of the iceberg, but ways that we can address the challenges in a fundamentally different approach than what we've done in the past. And these are some of the areas that are very, very, very important. And this is also, again, why I'm so excited. I'm Premier Li Keqiang, when I was in China, he said, I was the son-in-law of China. So in some ways, I think of myself as being part of the Chinese American Semiconductor Professional Association. But I think, again, you know, and I'll say this over and over again, every one of you, all of you young people here, you're at the foundation of changing the world. All of these things we're going to do differently. To me, I get inspired by all of this. I love the technology that will enable the future. And all of you, China, Taiwan, you know, all of these regions, they will be transformed in fundamental ways, faster than any of us can imagine. And we're there at the foundation of enabling that. I don't know what we could do that would be more fun than what we're doing today. So if you look at the memory business, in the 2D shrinking, you have like single-story ranch houses, and then running out of electrons in the cell, hitting cost barriers. What happens? We stop shrinking in 2 dimensions and we went vertical. And I fundamentally believe, as I talk to CTOs of chip companies, and I meet them all almost, again, on a weekly basis, there will be fundamental innovation beyond what people can see today, and the structures and memory and logic and building chips similar to what we see here in going from 2D to 3D NAND, you'll see innovations with materials. Very fundamental innovations. This is a great example. So if you look at transistor scale, as you shrink the transistor, when you turn the transistor off, you fundamentally don't want any power leaking through that transistor. And as you're shrinking it, what this graph shows, this is a poly gate. So I have leakage on one axis here. You can see different technology nodes, equivalent oxide thickness on the x-axis. And what you see is you shrink that transistor, you start leaking more. So that's power loss. That's a bad thing. It's a bad thing when you're trying to improve performance per watt. So what happened? The industry innovated with high-K metal gate. 10,000 times improvement in leakage current. But look where we're at today. Again, leakage current is getting worse. So, within applied materials, again, we're trying to look at how we build these structures in fundamentally different ways. So, we have materials innovation. Actually, at the AI Design Forum in July, I labeled this top secret. But again, 1,000 times improvement in leakage current is a really big deal. Really big deal. Fundamentally different structure in how we build that transistor. Thinking about the problem in a different way. Another one is placement errors. So when we're building all of these structures, all of these different layers in a semiconductor device, one of the biggest challenges is how you align one layer to another layer. So when you look at some of the most advanced structures, you have over 100 billion connections that have to line up correctly. I mean, that's mind-boggling. And we're going to hundreds of billions of connections that have to line up properly. So, I guess I don't have that on here. So again, this can be addressed by materials. The holy grail for everyone is a fully self-aligned structure. Fully self-aligned structure, 100% self-aligned structure from one layer to the next. And as I'm building these big AI accelerators with over 100 billion connections, this type of structure is really one of the key limitations to future scaling. But if you can fully align it, then by definition you have 100% alignment on all hundreds of billions of those connections. Very, 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 very critical. And again, this is really enabled by materials innovation. Packaging is another area. So if you look on the left here, you have a GPU surrounded with high bandwidth memory. And the packaging technology, in this case, can deliver 50% lower power consumption and 3x bandwidth. So certainly we have to innovate, not in small ways, not in the same path that we're on today. We have to innovate in new ways in terms of chip technology, but also packaging is really important relative to getting that 1,000 times improvement in performance per watt. Very, very, very critical technology. This is another thing that we're very focused on within applied materials, enabling fundamentally new technology and packaging that will deliver huge improvements in power consumption, and speed is really important, especially in an AI world. Speed is very, very, very important. So you have this new playbook. Also, what we've been driving in applied materials over the last 2 or 3 years is connectivity and speed. So when I go, there was 1 week a few months ago where I was with the head of R&D for a large Taiwanese company, a large Korean company, and a large company located in Portland. You can guess maybe who those companies were. So I spent hours in the same week. I don't know how many people have been in those kind of one-on-one meetings for hours in the same week. But, one of the people I was talking to, he said, Gary, he said this one material is really great electrically, but I can't integrate it into a chip. I can't planarize it. I can't remove it. So it's very, this connectivity inside a company is very critical. The ability to accelerate time to market and think about how you build structures in fundamentally different ways is really, really, really important. And I've told people that in the last year, I've learned more about what I didn't know than in my whole lifetime, which I think is a really good thing, because having that insight into what I didn't know helps us also think about different ways to approach the problem. So we've again, relative to connectivity inside Applied, we've focused in a different way. We've organized in a different way. So whether it's unit process or single step around depositing, removing, planarizing, modifying, analyzing all of those materials, thinking about how do we do that so that material that gives the right performance per watt can also go into a structure and be integrated. It doesn't help to have a material that can't be integrated. So making that connection is important. And the other thing that I found is if I look through the ecosystem, so inside the company connectivity is important, but also in the ecosystem, when you go from materials to unit processes, to integrated processes, to structures, to devices, to packages, to systems like an AI server, people speak different languages all through that process from materials to systems. And so, really, the insight that I've been able to acquire in the last year is understanding the person that's driving the chip design. Many times will give the unit process engineer or module manager a task to create a film or remove something or planarize something, but that connection about what's possible is lost. And for sure it's lost by the time you get to designing a system. So that connectivity in the ecosystem, from materials to systems, and inside, connecting those different capabilities, is really fundamental. When I talk to investors, and I ask them, what is it worth to have the winning AI chip 12 months earlier? What do you think the answer is? Anybody, just tell me what you think the answer is. Winning AI chip 12 months earlier. What's it worth? 10 billion. I have 10 billion. Anybody else? They say $100 billion to be first. $100 billion. So then for me, I talk to our team, what is it worth? What's a month worth? I mean, you're all scientists. I think you can do the math. What's a day worth? What's a minute worth? Again, it's worth a lot of money. So our goal is to go from materials to systems 10 times faster. 10 times faster. It's very, very, very fundamental. So speed and connectivity, inside and outside through the ecosystem, bridging these degrees of separation that exist in the ecosystem is really fundamental. It's very fundamental to come up with this new playbook. So, for everybody here that's an AI expert, I'm using AI analogies here around neuromorphic and von Neumann architecture. So it really comes back to serially thinking through problems versus trying to parallel process this challenge. And that's why, again, connectivity is so important. Connectivity, I believe deeply that those companies that connect differently in the ecosystem will be the winners. I deeply believe that. Because the playbook is running out of gas. We need a new playbook. All of those things I talked about earlier are possible. And that's the tip of the iceberg. So again, how do we accelerate these changes? Again, it really comes back to this neuromorphic mindset. Parallel connectivity, bridging these degrees of separation in the ecosystem. So, I deeply believe, deeply believe, Chinese American semiconductor professionals, you guys are in the best place ever in our lifetimes, ever. AI will absolutely transform major industries and create trillions of dollars of economic value. And hardware is sexy again. All of those people building hardware, all those people building chips. Now is a great time. Because at the foundation, the 1,000 times improvement in performance per watt is really at that foundation. We're there. We are there. Now is our time. Materials innovation is absolutely crucial. And this connected ecosystem and speed. You know, I really believe, as I said before, I get inspired by all of the young people I work with. All of the young people I work with, I have never had so much fun in my entire lifetime. And I would encourage all of you, we all have to think differently. For all the companies that are here, we have to connect differently. Also, I would say, for all of those people that want to make possible technology that shapes the future, Applied Materials, our doors are open. We would love to have you join us and connect with us. So thank you very, very much. Thank you.
Thank you very much. And stay on stage. Yeah, and we're going to have our past President and Chairman Brandon and our new President and Chairman Danny come up. And you're going to take a photo.